Hello, can you hear me okay? Good. Awesome. Thank you so much, guys. My name is Kevin Jones. I'm going to be doing like the first half of the talk today. And I'm going to be kind of focusing a little bit on the graph portion of this, because I do work for Edge and Node as a DevRel engineer supporting the graph. We're going to basically talk a little bit about the data for a Web3 application or a decentralized application. And then we're going to go into like what a decentralized front end looks like to truly decentralize your application. So first, I think generally probably here everyone knows what a smart contract is. We don't really have to get too technical on the smart contract aspect, but I always like to kind of look at one example, particularly CryptoPunks. So it is an ERC 721 smart contract, essentially, that is really just keeping track of specific data storage for all of the unique NFTs within that contract, right? So it's an ERC 721. So if we were to load it into Excel, it might look something like this, right? You have your IDs, which are the particular NFT ID, right? 0 to whatever number of NFTs there are. And then you have the owner, the current owner. If you were to kind of check and say, hey, who owns ID 0? You could query the smart contract and get that owner back, right? And then you have the metadata URI, which is basically for an NFT contract. It's just where all the details are about like, you know, what the traits were of the NFT, where the image is residing, or if it's an SVG, the SVG data. But it's all the details about the particular NFT, right? So it's pretty obvious. It's just a data store. And if we want to make transactions against that smart contract, we update that. If we want to trade or sell an NFT, you propose a transaction to buy or sell or do some kind of transfer, right? And then that changes the state. It's pretty straightforward. But there is one problem with blockchain specifically. And the main issue is, well, one of the first issues, there's a few issues. One is there's a lot going on in a block. In like one single block, there's all sorts of smart contracts and all sorts of externally owned accounts that are contacting each other to do balance updates, state changes, contract creations, and it's a little bit of a mess. If you want to like parse through it, there's no really easy entry point into this the block to be able to get that data and organize it in an easy to read way. We also have this initial architecture where like the concept for an initial dApp was you have a user interface that you hope would be decentralized, stored on like IPFS or some kind of decentralized data store. And then your smart contract, which has the business logic for your dApp, lives on the blockchain, and you would read and write. But the main issue is that most blockchains, or all blockchains, are really incentivized for writes. So there's a security layer that's in place for the consensus of the actual transaction. You know, you do have to sign your transaction with your key. You got to pay some gas, right? And the gas kind of ensures that your state change gets picked up and that you've kind of like paid to make this change. But there's no incentive for reading data, right? And the original implementation of the blockchain was really not designed for reading data. It's a JSON RPC, and it's really designed for like being able to read single state of a particular smart contract, or maybe a balance, or managing your node over JSON RPC is definitely a common thing. And so reading is very slow and just difficult to do. So we often see like this kind of situation where this is an example of someone who wanted to query all of the NFTs that a particular owner had in their wallet. And we can see here that we're actually having to bounce around on the over and over and over and over again to get all of the NFTs and then display them after pushing them to one data object, right? And so this is okay if you only have like 1 or 2 NFTs in your wallet, but if you have 10, 20 NFTs that you own, this could easily take at 100 milliseconds each time, upwards of like 10 to 20 seconds to load a page, which is not a good user experience, right? We also have this issue with provenance. So we can't really see like historical data on the blockchain easily, right? You can't like go back and say, oh, well, I want to query like this specific state of time. Like in other words, who owned a CryptoPunk at one state of time, right? It's very difficult to do. And so one of the problems is, like I said, you can't get access to that data. It's just not easy to do. So this is kind of, these problems is what the graph aims to solve. The main concept for the graph is it is a API or a set of APIs that are designed for decentralization. So, and it's an indexing protocol. So We allow querying of networks like Ethereum or other blockchains. Sorry about that. And then also IPFS and Arweave we can index as well. We can index that data. And the concept, again, is to provide APIs for smart contracts on the blockchains that we support. So there's about 1 to 2 billion queries per day going through the graph, which is pretty hefty. And the APIs are exposed with GraphQL. So that same kind of code we saw earlier, where we're actually trying to get all the NFTs, we had to loop through and query the RPC and do ETH calls. We can do with one simple GraphQL query, right? That's the beauty of GraphQL. You say, hey, this is exactly the data that I want to get. Provide me that data back in one JSON object, and then you can parse it in your front end. So the graph is a decentralized indexing network and protocol. And what that means is it is a decentralized network. There's over 400 indexers. So an indexer is a participant in the community or a participant in the network that literally runs the stack for indexing the data on their server. And that is a combination of Graph Node, Postgres database, and the GraphQL API and IPFS that is exposed. And then the idea is that this data is decentralized and open and available to anyone, right, that has access to the network. And it's also redundant, right? You have this data literally distributed, and the way the data is retrieved, you can always kind of guarantee that you're going to get a response from the network because it's highly available. And it's also a lot cheaper because the indexers are incentivized to make that data available at a more larger scale in an indexed, decentralized way. And really, like I said before, is that the idea is to have global open APIs for specific blockchain data and to build truly decentralized apps. So I think we, in Web3, we kind of gotten away from this over the years. And I think it's really relevant to the conversation today and the demo that we're going to give because it really does put the power back into this concept of fully, truly decentralized applications. Combining the data layer with the front end being decentralized, with the blockchain being decentralized, you really can build truly decentralized apps. So what exactly is a subgraph? I've said it a couple times, but if we talk about the graph, the main thing that powers the graph are subgraphs. You can think of a subgraph as a database or a collection or an API of exposed data that we care about on the blockchain. So we kind of go back to this solution or this diagram where we see like a lot of blockchain transactions that are going on in a particular block. In this case, we have Foundation, we have MakerDAO, we have Uniswap, Aave, UMA, Zora. There's lots of transactions going on, and the concept is to create subgraphs for each particular protocol or each particular smart contract. And so we can easily query and index the data that we care about, and the protocol itself can build APIs that are easily digested for other applications as well. So this is kind of what the architecture looks like. You still have a decentralized application that you deploy. So in this case, on the top, let's say we are deploying to some kind of decentralized network. You're still proposing transactions like you would normally do for writing to the smart contract, right? So you're writing data to the blockchain, and as your smart contract emits events, the graph node, which is the kind of like the workhorse for the graph, picks up the data from the event, right? So if the event, you can think of an event as a log. I think in general, most people here know what that is, but an event data keeps track of like what changed in the transaction, what variables were, at the current state, like booleans, integers, strings, any kind of data you care about in your smart contract that you want to emit an event, you do so. And then the graph node picks up that data. And then based on what's called a mapping, the data is then transformed and stored in a schema, in a specific format that you create as a subgraph developer. And it's stored in Postgres. And then Graph Node itself then provides a GraphQL API for the data. So the data literally is living in Postgres, but there's a lot of other fancy stuff that goes on under the hood in Graph Node to expose that data and make it easily queryable for your front end. So you can, instead of having to do reads from the blockchain through ETH calls and stuff like that, you can just query the API. So this is live footage of a subgraph in work. Just a little fun example. But yeah, all this mess of stuff going on, everything's getting organized for you as it's passing through the blockchain, and GraphNode is kind of organizing that into buckets. So I did a good workshop on this. We're not going to get too much into like the subgraph creation itself, but I did a workshop here that goes into really good detail about how to write a subgraph, how to develop a front end. So this would be good to check out if you really want to kind of dive in more to the subgraph development. It's also available on YouTube. So if you go to the House of Web3 at YouTube, it's available on there as well. Or if you just go to bit.ly/fullstackdapp, that will give you the workshop as well. Let's see here. I don't know what's wrong with this slide, but it never works. Okay, so let's look at some data. Okay, so we've been talking about CryptoPunks, right? Where would you want to go if you wanted to learn about CryptoPunks? Anyone in the crowd? OpenSea, that's one place you could go. Not for long. What about Etherscan? Maybe you try to go to Etherscan. Well, those are both centralized solutions. Maybe you just go to the CryptoPunks website, right? And you say, all right, well, I care about CryptoPunks. I want to see what's going on. And we can go down here and we can look and see like, oh, let's look at what's the most expensive CryptoPunk ever sold. Well, we look right here. The most expensive one here was for 8,000 ETH, number 5822. It's a lot of money. Anyone here on a CryptoPunk? Secret whale in the crowd? No. Anyway, so there's a lot of money being transpired on or transacted on CryptoPunks. And if we go to like a centralized solution like this, we could say, oh, like what is the most expensive CryptoPunk? We can kind of see it here. What is the data correct? We don't know that. So we might look at something like DAppLooker, which is powered by the graph. DAppLooker is like no code front ends. And we could come here to I did a search earlier for like CryptoPunks. And we come down here, we can see like volume, we can see the 30-day transactions. And we look here, we go a little bit further, we see top 5 most expensive CryptoPunks. And actually there's one here that's 124,457 Ether. So it actually doesn't match what's on their website. So let's pretend that we're one to look at what the graph has to offer, which we know that DAppLooker is powered by the graph. We can come here to products. We can go to, you have a question? Yeah. Is that the listed price or is that the sold price? That is the sold price. So we could come here to Graph Explorer. Now, if you go to thegraph.com, the first thing it's going to ask you to do is kind of choose what tool you want to use. So Graph Explorer is kind of like all of the subgraphs that are on the network, on the decentralized network, are going to be listed under Graph Explorer. There's also the hosted service, which is a hosted set of data that we store, but we're moving away from that. So you should use the Graph Explorer. And then we also have the Studio. So before we get to the Studio, let's go to Graph Explorer and let's connect our wallet. Actually, we don't even need to really connect our wallet. Let's just do a search here for CryptoPunks. And then we get like a few different CryptoPunks examples. And generally what you want to look at is like the signal. How much GRT is basically signaled for that subgraph to be picked up by the indexer. So you can think of the signal as kind of a signal of like the market and how much it cares about that subgraph. So just for the sake of this one, there's 2. They're very similar. This one's got 10,000 GRT staked. This one is 17,000. So let's choose this one just to kind of, because we know, well, I know it's got the data I care about. We can see like there's been some versions over the period of a year. And we can also see that it has, let's see, it's got a GitHub repo, so we could click on that. We could also get some information about it. We could see how the documentation is, right? So we could actually like look at the source code for the subgraph. But more importantly, I want to show you the data. So there's a playground here that we can click on. And we can also see that it's fully synced as well. So you can see right here it says indexing. So it's at 100%. So we know it's not broken. There's nothing wrong with the indexing of the data. And then we can look, there's an example query that I could just grab. It's grabbing a bunch of data that's kind of predefined here. But let's look right here. There's this, and by the way, can you guys see that okay? There is a Explorer. So right here on the right-hand corner, The beautiful thing about GraphQL is if you have a schema defined for a particular API, all of the information that is in the schema is inside of the Explorer and the objects. So if you were to look at this with GraphIQL, or in our case, we have our own implementation of this in the playground, we can go through here and browse through all of the data that's available inside of this subgraph. So let's just get rid of some stuff, kind of clear it out. And let's go ahead and take a look at what we care about. So we want to look at sales. We want to grab the first 10, sure. We can order them by the amount that they cost, or that the amount, I guess, that they were sold for. We can also change the order direction to descending. Then we can display the ID. We can get the NFT that was. Yeah, I think I can go like that. There we go. How's that? Better? Yeah, it's really hard to look at. Is there a... Oh, yeah. Okay, I might have to shrink it back down. But anyways, so then we can look at the punk. So first we can get the ID of the punk. Then we can grab the punk, and we can get whatever we want. So in this case, we want to get the total amount spent, I believe, and hit play. Let's see. And there we go. So we can, I got to shrink it back up again. But here we got a response back. So we did this GraphQL query, which is grabbing the first 10, order by the amount, descending order. We're grabbing the ID of the actual NFT, the ID of the subgraph store, which is like here. And we can also get the ID of the actual punk right here. So this one, we can see the second one is the one that was actually 8,000 ETH. But this one was the one that was much higher. So we could grab this particular CryptoPunk if we wanted to. We could probably dive in a little bit longer. Just for the sake of time, I'm not going to do that. But if you were to look on Etherscan for this particular token, what it was a flash loan. So someone actually borrowed 124,000 ETH, bought the CryptoPunk, and then resold it and sold it back. So they censored that. They censored that transaction on the DAppLocker website, or I'm sorry, on the CryptoPunks website. But the data we know that doesn't lie. That's what's available in the graph. So that's just one example of why the graph and decentralized data is important, right? So let's say that in this case, we already have a subgraph that's available for us, right? You might not always have one. Let's just say we wanted to create one for CryptoPunks. We could grab the particular token for CryptoPunks, and here's the actual address. Am I like boring right now? Oh, it's right here. Okay, so let's just say we want to, this is the address for the CryptoPunk. We could come over here to the Explorer, connect our wallet. So the first time you ever connect your wallet, it's going to ask you to, actually let me disconnect here and let me switch the identity to a different one just so I can show you guys. Connect, MetaMask. Okay, that's not working. But anyways, it's going to ask you to like create an account or sign the account. So the first time you do it, you'll actually sign. Then if you go to Subgraph Studio, here it is. Thank you. All right, so Subgraph Studio, it's going to ask you to create an account. So you say sign. And then we can go create a subgraph like this. We can call it CryptoPunks. I don't know, we'll just do A. Select the blockchain, so it's Ethereum, and then create the subgraph. And then what this is going to do is it's going to provide us kind of like a skeleton for our subgraph configuration that we want to create. And if we come down here to the right, we can see all of the steps that need to be run to be able to create our own subgraph. So the first thing you have to do is install the CLI. So it's a global CLI that essentially allows you to interact with the studio. So I've already done that, so I'm going to skip that one. But if you do that, you can either do it with NPM or Yarn. Then what we can do is initiate the CryptoPunks here. So we can grab this. So let's just go, we'll do this. Indicator A, CPA. All right, so let's do graph init, CryptoPunks A. Let's choose the blockchain. So we know it's Ethereum. It's going to ask us what we want to name it. I'm just going to call it CryptoPunks A. Put it in the same directory. And this is on mainnet, and then it wants the contract address. So let's grab the contract address, which is right here. Paste it in there. Now what's going to do is it's going to go out to Etherscan. It's also going to fetch the ABI. So if you've verified your contract, if you deployed it on a testnet or on your mainnet, you've most likely have probably submitted the ABI there. So that's important. So we already have the ABI on Etherscan. It grabs it, and then the only thing it doesn't know is what the start block is, or maybe it does actually, but let's just double check. So let's look at the contract creation, which is here. There we go. Oh, it did grab it. So 391. So it did grab the start block. And then the contract name. So we'll just call it contract. And then this is very important. It's going to ask us if we want to index all of the events as entities. So what it's going to do is like assume that you care about all of the events that are inside of the ABI. Okay. If you do true, it's going to read in the ABI and automatically create the configuration for you. If you want to do it by hand, you would say false, but we're going to let it do it for us. So just like that, it read in all of the event data, created the subgraph configuration, and now it's just installing all the dependencies that it needs with Yarn. And then it's generating the ABI and the schema types using what's called Yarn CodeGen. And then it asks us if we want to add another contract. We just say no. So we could look at this if we want, but for the most part, everything that is in here is going to be automatically created for us. So it automatically creates the subgraph configuration, automatically creates the schema entities that we care about, and it automatically creates the mapping file for us as well. So if we wanted to, we could deploy this one. So let's just go ahead and do it real quick. I'm not going to walk through that. My other workshop goes into really fine detail about how that works, but you don't really need to know because it writes it all for you. So let's go ahead and just deploy it real quick. So let's auth first to the studio. So this is going to create like an API connection between my CLI and the studio that I have signed in. Go into the folder where the CryptoPunks is, do the CodeGen and graph build. Going to compile it for us and get it ready, and then we can just deploy it. So it literally walks you through a very good developer experience if you're writing a subgraph. And then we can just choose what version that we want to deploy. So in this case, it's just version 1. So it's going to take our subgraph, deploy it to the studio, and start indexing it. So as soon as it's done here, it's going to give us the URL for the graph IQL if we wanted to query it right here. But we can also just go back up here and start looking, and we can see that it is fully indexed. Now, the reason why it's fully indexed, normally it would take some time. Like if it was your smart contract, it would have to actually go back in time and like parse all the blocks. But someone's already deployed this smart contract. Someone else has come through. It was probably me actually that just did the basic CryptoPunks example, deployed it, and so the hash of the subgraph basically matched, so it's fully deployed and available. And then we'd be able to go to the playground and look and browse the data that we care about. Okay. Now obviously this is a completely different subgraph than the one that we showed off earlier. The other one was a lot more detailed and it's doing a lot more fancy stuff, but it's that easy to create a subgraph. It's really easy. Okay, so any questions about subgraphs or the graph particularly before I pass it over to show how we can consume that with the front end? Yes.
A little bit off topic, but the kind of tokenomics side of things, like how do you actually verify that? Like what's the point of the token? Like use to stake on a certain graph, but what does that really mean?
Yeah, good question. So in regards to like GRT, so if you are a developer and at some point you let's say you've created, in this case, we've created this particular subgraph. Let's say I wanted to actually publish it to the network. I would want to signal that someone should pick that up by paying some GRT. So you're basically like paying like as if you were paying for your AWS or for Google Cloud. You would need to spin up an instance and pay for your monthly fee to get the data stored where you want it. You can think of it the same way. You're basically paying these indexers to pick up and store your data. So you would come here and say publish. You choose what network you want to deploy it to. We support the test nets, Arbitrum and Ethereum Goerli, or mainnets, Arbitrum 1 or Ethereum. So Arbitrum 1 is obviously recommended because it's a little bit more gas optimized. You would then choose how much you want to signal. So in general, it's 10,000 GRT is enough on mainnet to have someone pick up your subgraph and start indexing the data. So you can pay 10,000, and then after you have published your particular subgraph, you would need you want to query it. Okay, so that's where you would actually create an API key.
Sort of serve as some sort of business model for subgraph developers. Like, how do they make money?
Yeah, so the indexers make money by serving the queries. They get some level of query fees. I don't know exactly how the tokenomics work perfectly, but for the most part, if you signal for a subgraph and people query against it, then you can make some essentially back on the queries that other people do against the subgraph. Yeah, it's probably a little more technical to really explain, but.
Are there people that like make money doing this, like just creating these indexers?
Yeah. Oh yeah. Absolutely. Yeah. That.
Full-time subgraph developers.
Yeah. Yeah. I mean, there's also one of the core devs for the graph is Masari, which if you go to subgraphs.masari.io, there's a whole bunch of subgraphs that actually were created from a grant, actually from the Graph Foundation, that are like industry standard subgraphs. And so if you guys are looking for a specific subgraph, all of the Masari ones are very good, and they kind of this go in more into detail about what their current status is. So if you're looking for like a DeFi particular one, you might want to come in here and look at do a search for it if you want to query those subgraphs. They all have standardized formats as well for them, so like you can kind of assure that each subgraph for that particular category is going to match very similarly on the data types. Good question, though. Any other questions before I pass it off? Cool. All right, now we're going to show how we can like integrate this into our front end on Jutsu.
Hello. Mic is on? I don't know. I did not mute. Oh, I think it's on. Okay, so hello everyone. I'm Zahid, the founder of Jutsu. So Jutsu is a developer platform to build and deploy decentralized frontend. So how many of you are Web3 developer here? How many of you are developer, know JavaScript, build something in JavaScript? So almost everyone. And how many of you are consider yourself a front-end developer? Perfect. So if you already build anything in React and deployed anything using React, you can build and deploy decentralized front-end using just React. I'm not going to show any slide, so I'm just going to go straight and then start building something. So this is the, I think the most, can you see the slide? Better? So if you want to follow me and coding, so just go to Jutsu.ai and then log in with your GitHub profile. So you can, yeah. No, just follow for the time being. So when you go and sign up, there will be a flow where it will generate a UI for you. So you can choose either if you want to build a NFT marketplace or a DAX or a simple Web3 apps. So, and then it will generate a code for you. But my goal for this meetup is basically showing you how easy it is to build a decentralized frontend. So because we saw already how much important it is to build it end-to-end decentralized app. Okay, so how many of you want to follow along? Okay, so let's go to Jutsu.ai and log in with your GitHub account. Just let me know when you are there. So perfect. Perfect. So then we can create a apps like which I'm not creative about names, so I'll just call it dApps, which is the apps. So you can see, make it a little bit bigger. So you can see already. So this is a web IDE that where you can write your React code, and you can see live preview in your right side or left side. And this is the folder structure. So if you already know Visual Studio Code, it's already home. So it's use exactly same format like Visual Studio Code, but everything is web based. You don't need to install anything. So and then if we want to add anything here, so like Zahid, so you can see you get the library load. And if you want to deploy, if I want to deploy this thing, then right now I'm logged in. So like if I'm not logged in, then it will ask me to connect. So this is another part. Jutsu today deployed the front end on Near protocol. So if you don't have a Near account, you can go and get a wallet. I would suggest for the sake of this demo, let's choose the testnet. So if you go down, you can choose mainnet or testnet. Okay, so just to choose testnet, and then getting testnet account is easy. So for this example, I'll just log in with my testnet. If you need mainnet wallet, so you can just come to me or Cameron there. So like you can get a wallet from mainnet. Okay. So this is a basic React app. So if you already use React, you know how to use state. And this is a simple counter app where we are storing the value in a state, and then we are updating. And then we can just deploy this app in Near protocol. So this code is nothing different in terms of, as a front-end developer, it's exactly same the way you'd write a React code. But when you deploy, we'll package this code and we deploy directly on Near protocol, on-chain. So this UI, so you can think of it as a on-chain React. So anyone have any question about like how it get deployed or yeah. Great question. So the question is like, what is on-chain uh, React? So typically, when we build a React app, uh, we deploy it on a centralized storage, either Vercel or S3 bucket. There are some example of decentralization where you can package your front end and deploy on IPFS. But the challenge so IPFS is a decentralized storage system, so where you can store your front end on IPFS. But the problem with IPFS is you don't have a guarantee of the storage. So your file can get lost unless you pin those things. For our case with Jutsu, we take this front-end code and then we deploy in a smart contract. It's called near social smart contract. So the benefit of storing this deploying this code in a smart contract is you get all those histories. So if we go here and then you can see like all the history of commits. This one have one commits, but let's say if I go more, so you can see like this one have all these different commits, and you can see all the different version of this website, and all this code are on chain. So imagine a scenario where you want to guarantee that something that is running in your front end and that part is still in the back end in a smart contract, so you can guarantee that part because of the code deployed on a smart contract. Then, so let's go back and then, so now we talked a lot about the CryptoPunk. So we know that Graph provide you the decentralized indexer that provide you the data, decentralized data. So let's go back to this example that Kevin showed. So where you can access all the data related to CryptoPunk using this playground. So as long as we have this data, and this is the GraphQL part, we can access that data in our decentralized frontend and then show those data. So if we go back, this is this is the query that you have to, when you go to the create your account, you'll get a API key, and then you will use this API key at the end of your query. And this is the main GraphQL query. So we are saying like, okay, we want the amount for that punk, and then we want the token ID. And in the metadata, we want the token URL and SVG. So right now, the SVG is a little bit broken. So, but maybe that will be a homework. So just to explore how to parse the SVG and show. But other than that, here in this query, how many of you know GraphQL query? So it's a very simple query language where we are saying like, okay, give me the top 10 cell, order by the price, and the descending order. So the highest price will be the first one. So so that means this CryptoPunk 9998 is the highest priced, most expensive CryptoPunk. So if I click, then I can go and check detail about that that CryptoPunk, that NFT. Then rest of the code is just a typical React code where we use fetch API. So we use fetch API to call that graph endpoint. We get the data and we parse the data from the body and get the cells, and then we store that cell in a state. So we have a state called items, and then at the end we just loop through that items and we show that items here. So each of these items in the right side are coming from the item from the data that we get from Graph API. And then later we are just showing those different attributes. So in this case, we are showing the SVG, and we are also showing the token URL that makes this click that point to the actual website. So rest of the thing are kind of traditional React, and you can just one click you can deploy. So this will show you like what is the code current state, and then you can just push this code. So this code will be deployed on near testnet. So let's see the internet. Internet. Yeah. That's a great question. So it works similar like IPFS or Graph. So we have a lot of proxy gateway, and you can run your own gateway. So like if I click this one here, so you can see like this same front end I can access from any of these gateway, and then the gateway is kind of growing. And so if I want to open with Jutsu, so it will open with Jutsu. This is like let me show you another example. So let's see if I go to mainnet and then connect my wallet. So I'm going to show, okay, so I don't have a mainnet wallet, but okay. So let's connect again, testnet, connect my wallet. So if you know about like a IPFS have different gateway, and then you get the content ID, right? So if you have, as long as you have the content ID, you can access that from any of the gateway. For our case, if you have the component on chain, then you can access from any of the gateway. And then you can also run your own gateway. So gateway is just a small piece of code that knows how to read the block from the blockchain and then render that in the front end. So it pretty soon will kind of share a npm package that you will run, and even in your web 2 front end you can deploy them. That's a great question. So this is the website for NearCon. So Near is organizing the conference, NearCon conference. So if I want to access this front end, so I can go to, let's say, near.org. So there is this website, and then from there I can access NearCon. App or component. So this is, let's say, if someone want to access this app, they can come here. They can also go to Jutsu.ai/nearcon23. So this is another way they can access. Also, they can go to something called near.social. You mean that as long as you know okay, so the question is, how do you know how you can access that app? So every gateway designer, so they have some sort of search capability, but as long as you know the name of the component, the account that deployed, and this is the name of the component, the index, you can access it from anywhere. Then the gateway specific people, they can add their own kind of a custom thing. But if you want to, like a nearcon is going to run their own gateway, then it will be like a nearcon dot, then that will render this page. So the idea is you can go to any of the gateway that right now probably we have 10, 15 different gateway. So if someone want to censor your front end, you can go any of the gateway and your front end will be live. So it's not going to go down. So that's the bigger advantage. Someone can block your DNS, but they cannot block your app. So that's the one of the main benefits. So same like in Near Social, you can come to Near Social and you can still access that app. So if I search for NearCon, so this is the one, then you can see the same front end show up in any of these gateway. So the idea will be every Near validator in the future will run this piece of code, and then you have a truly decentralized gateway. So someone can censor your DNS, but not censor your app. So that's the main idea in the future. There are a few other things I want to show. You saw Graph, how easy it is to kind of build and kind of compose. Like you saw, like someone already built CryptoPunk subgraph. So when you come to Jutsu, another thing you'll notice. So let me go to the mainnet. So this, by the way, this app is on mainnet. So people are already a lot of people are using it, and these are all the different apps that are deployed on mainnet today. Let me make it a little bit smaller. Is it better? Okay. So these are the different apps that are already deployed on mainnet. The beautiful thing is, let's say I want to start a NFT project, NFT front-end project, a marketplace. I can just come here and search for NFT. And let's say this is a marketplace, looks like. I can go and check, okay, so how this marketplace look like. So I can see the code, all the code, I can see how it will look like. And now imagine I want to start building something similar. So I don't have to do anything, and I can just come here and fork this thing, and that will load in my editor, and then I can just start changing. So let's say instead of NFT marketplace, NFT marketplace, I will say like, okay, it's my marketplace. And then you will see the real-time update, and then you can connect your wallet and you can deploy. So just imagine like how interactive and how easy. So you can take someone's code and compose and build your own apps. So that's the another benefit of decentralized frontend is the composability. And last thing will be so if you want to learn more about Jutsu, so we have a learn section where you can go and you can find how to access a API or how to access the clipboard, smart contract interface. So this learn section is growing, so you can just go and this learn section is very interactive. So let's say if I want to show all the different type of cryptocurrency, so you can just go and check how to fetch those data, and in the right side you have the entire code, and then you can see the real update. And the same way, so the goal for learn section is kind of just learn by building. Anyone have any question? Yeah.
What's the average cost like per byte to store data? Is there like an estimate?
So great question. So if you go to the editor in the bottom which side? This is right corner. So in the bottom right corner, you can see the average cost will be like this marketplace will cost 0.03 near. So 0.03 near probably right now. How I don't know exact. 3 cents. Yeah.
Wow. It's perma storage.
Yes. So this is another thing. Like you mentioned, like the blockchain was not designed for GET requests, right? It was designed for storing data and making it secure. So we are kind of taking the advantage of that, where when you deploy your you deploy your front end, you have a storage cost, but access is free. So that's why if you go to our website, it's called Deploy Forever. So the reason is you can deploy and your code is forever there, and you can go to any of the gateway and access your app. So that's the kind of the advantage that we are taking from blockchain. Yes. That's a great question. So you can deploy your front end for any smart contract from any EVM chain, so Ethereum, Polygon. But because we are deploying the front end on Near protocol, so you pay only Near. So that means your front end will be still cheaper, but you can fetch data from any Ethereum protocol. So again, like if anyone want to start exploring this thing, I think the first thing will be come to the apps or components and then start searching like I don't know, Uniswap. So you can see in our platform also like probably 20 people build some version of Uniswap front end. So let's see, this one looks interesting. So you can open that one and then you can see it's not really Uniswap, it's a staking, but it is using Ethereum. And if you see the code, like you'll find one interesting thing is there is nowhere in the code you write code for connecting the wallet, right? And because our framework inject all these things for you as a developer, we want you to write the minimal number of code, and we want to kind of by default constrain the framework such a way that you don't make a lot of simple front end security mistake. So we believe everyone should build and deploy a decentralized front end, and every front end should be safe. So that's the idea. So if you want to build a Uniswap today front end, it will probably take you a week. But with this, with Jutsu, you can come and you can start, you can fork this component and uh, you can start changing the contract address to your contract address and start testing, experimenting with the UI. So it will take you probably a day or two, not like a week or month. Yes?
This could be like any ETH or near app, like essentially built as a component that's forkable.
Yes, any EVM, right now we support any EVM protocol. So Ethereum, Polygon, Polygon ZK EVM, so any base or any EVM chain. But we are also working on optimism stack. So it will be multi-chain. It is already multi-chain, but we are gradually expanding, supporting different backend. Yeah.
Are you thinking about having some kind of CLI so we're like, if you, let's say you ran create React app, and like built your app, where you can just run a command, ship it to Jutsu, and then like basically like do you have a CLI plan, and like is that the market you're going after, or is it just the UI version?
So right now it's the UI, but in the future we have a CLI. But there are already community CLI. It's called like one of the CLI called Boss CLI, that you can use to kind of deploy this component from local. So there are like it's called Boss CLI. Yeah. So CLI is command line interface. So the thing that you run from your terminal. So these are so any command that you run in the terminal. So that's like a command line interface. So you can write a command that will do something for you. Yes, we have a plan to do that. And also like a VS Code extension in the future, so that some people might not want to go to the website. So we'll have an option for VS Code extension where you will still have the library load and everything. But so that's the future plan. Come on. Any other question? Any question?
I grabbed their website, and I don't know if it's functional, but I know you have to create, in order to fork the front end, it already has to exist. You wouldn't be able to find another website that you like and grab the front end and fork it into Jutsu. It will have to be already weak in order to, alright, you can't just grab another.
So as long as it is that front end is in blockchain, so Near have a concept called blockchain operating system, where there are a bunch of other this kind of tool like Jutsu, where you can also build and deploy your front end. So as long as you can come to this search section and find something here in your components or apps, so you can fork it. If it is not there, so there is another, so there is a part of Near, it's called Near Dev Hub. So Near Dev Hub is a community where if you don't have a component and it is, let's say technically it will take you weeks or months, if you want to develop or if you want to request, so you can go there and create a RFP, and then either you get some grant or some other, you find some developer who build that component for you. So there are grant program to build a new component. Yeah. No, fork is free. So at this point, there is no cost, but in the future, so one of the things that graph token economics work, we are not going to, not in the near term like a token, but the idea is, let's say Alejandra, she mentioned about, oh, this component is not there, but you are a super developer, right? So you build that component and then you will be able to sell it. So then forking, when you fork, you pay for that component in the future. So it will become a marketplace. So the community component will be free, always free. But in the future, you can create those private component and then sell those. Any other question? Subset. It is subset of React. It support hooks. It support state. It support context. The thing that we don't support right now is kind of security vulnerability, like where we don't expose the object uh, from JavaScript. So another important information is. So for security reason, we create a sandbox. We run the JavaScript in a sandbox because we don't, imagine like if you build a component and then component have access to your local storage, and all the wallet, they store keys in local storage. So we don't want to give you anyone to give access to this local storage. So it is a subset of React. The only thing I'm missing is the thing are security vulnerable to yeah, and then you can go and find all the document here. So if you go to the document, if you come to the profile and click documents, so you'll find all the document related to boss. They keep changing the the UI, so it's totally different today. But like if you go, which one? I have no idea. Boss. Okay, so now they call it overview. Okay, but like this is like if you want to read more about the entire framework, and then someone had a question about gateway, so you can learn more about gateway, how to run that, how to build a component. So you get the example. So that's one way. But if you go to Jutsu, also like if you want to learn by building, so you can also come here and learn very specific topic, like how do you fetch data from graph protocol, or like how do you display those data, so those kind of things. So there are some React developer here, right? So what do you think about how different it is from your day-to-day React development in terms of code? Is it approachable? Anyhow, feel free to reach out to me and give feedback. I'm curious to kind of learn how we want to make it kind of a one-on-one with React so that you don't have to learn any additional skill to deploy something on chain. So that's the goal. Yes.
So I would say, because like I typically use like Yarn to manage scaffolding projects, right? So that was why I asked a question about the CLI. But I also often use like code spaces. I can't remember the
Code sandbox.
Yeah, like some sandbox stuff. But I don't particularly like to develop browser based.
Yeah.
So I think if there was like an integration with like
VS Code.
VS Code, that would be good. Yeah. Or if there was just a way to do it with CLI and push standard React, or most everything I do now is like Next.js, which actually that's another question. How different is it than Next?
So we have kind of a framework like Next.js. So Vercel have this Next.js framework where they make it super simple for routing and all this different stuff, which is different than React routing, right? But for us, we are kind of adding all the functionality that as a Web3 developer that you will need, like a wallet, connecting different wallets, wallet selector. As a developer, you don't have to worry about okay, which wallet I choose, how do I integrate, how many line of code I have to write. So we abstract that one, but definitely I can see a value of CLI and extension. Right now, the primary target is like a beginner to intermediate developer, but pretty soon, the next thing will be a VS Code extension, where you can just pull all these things from Jutsu and then get pretty much one-on-one, like a live reloading and pushing the codes. That's the next one. Maybe after that, we can have a CLI where more hardcore developer who like Tmax, right? Or Vim. I like Vim. I used to work a lot with Vim. Any question? You can always find me. I'll be here. And then I come here. You can. Okay. Yes.
So after this event, Ed, and us, we're gonna have some drinks and food. So feel free to come outside. It should be coming in anytime soon. And
For anyone who want to build decentralized apps, both contract and mostly decentralized frontend, from November, right?
yes.
So do you have any? So just get the.
Best way to find out is through our newsletter. So once you RSVP, oh, not RSVP, once you join the newsletter, you'll get a email every week on event. We don't spam, we just do events. We don't really set our thoughts on anything, just events mostly. So, yeah. Thank you guys.
So I'll keep the laptop. Find me here.